Hey guys, let's do this problem right here. The question is asking find the centroid of the complex shape is in respect to the lower left hand corner. So, so this is lower left hand corner. So from this respect, we have to calculate the centroid. So first of all, so in centroid, so we have to basically calculate two things: this x bar and the y bar. So that's going to give us the location of the centroid. So for the to find the x bar, there's an equation for this one. For the complex objects, it's sigma a x bar over sigma a, and for to find the y bar, it's sigma a y bar over sigma a. So this is the equation we have to remember. And before we go further, we have to know exactly. So this is a complex object. Therefore, we have to separate it into simple objects. So in this case, we have a circle right here. So let's say this is my part one. So first one, and I divide this rectangle separately. So this is my second part, second section, and I am separating this semicircle separately. So it's going to be my third part. So these are the three parts I'm going to consider. And in this case, so before I do this one, I had to know a centroid of these three separated parts. So first of all, if you see the hole, this is a hole, right? So they mentioned it, and this is circle. So for a circle, the centroid is going to be exactly in the middle. So that's going to be easy. And for this rectangle, also is exactly in the middle, but in this case this is not in the circle because circle is 100-meter high, but the rectangle is 250, so it's going to be in 125. So it's going to be somewhere here, because radius is 30, it means 125 is going to be somewhere here. So this is the centroid of the rectangle, and the centroid of the semicircle, there's an equation for this. That's going to be somewhere here, and the equation for that one is 4r over 3 pi. So that's the centroid equation for the semicircle, and that's going to be somewhere here. And that's all we need to know before we do this question. And now we have to find these three things. We have to find ax bar, a sigma a y bar. So to do this, I create a table of contents. So in this case, okay, so let's list the parts. So we have three parts, so part 1, part 2, part 3. And to calculate the x bar, I have to calculate the area and the x bar, then ax bar, and then y bar, and then a y bar. So this all we need to calculate to find the x bar and the y bar. So the units are going to be, so let's say this is millimeter, these are given in millimeters, so this is going to be millimeter square. Area is going to be millimeter square, this is going to be millimeter, and area times x is going to be millimeter cube, and this is going to be millimeter, and this is going to be millimeter cube. And then let's find the areas. So to find the areas, what I have done, okay, so let's get rid of this. Okay, to find the area, so first of all, I'm taking this whole. So to a circle, the area is 5r square. So 5r square, and if we calculate, 5 is going to be 3.14 and r 30. So if you calculate this value, it will give you 37. No, it's 28, 27.4. 2827.4, and the x bar is going to be the distance from, so this is the point we are selecting. So whatever the for example x bar or y bar, you have to measure from this distance. So from here, the x bar is going to be the distance in the middle, is exactly in the middle, so it's going to be 75, and if you multiply both of them together, you will get 212,055, and the y bar is going to be the height from this one. So it's going to be, and it's given here, it's 100, so we can directly put it here, 100. And if you multiply this one with a, you're gonna get 2282740. So this is a y bar, and second object is the rectangle. We are taking this rectangle. For the area of the rectangle is going to be length times the width. So it's 250 times 150, and if you multiply both of them together, you will get 37500. 37500, and the x bar is going to be from exactly in the middle. It's going to be 75. So x bar is, yeah, 75. Then if you multiply 37500 by 75, you will get 2812500. And y bar is going to be the height from this one to the middle, so it's going to be 250 divided by 2, so it's going to be 125. So 125, and if you multiply this one with a, you will get 4687500. So this is my ay bar. And the third one is the semicircle. To the radius of the semicircle is only 5r squared by 2, because halves, right? So it's 5r squared by 2, and radius is given 75. And if you plug it into the calculator, you will get the value 8835.7. Then we have to calculate the x bar. X bar is going to be the distance from this one to the exactly middle of the circle. It's going to be the radius of the circle, so it's going to be 75. And if you multiply both of them together, you will get 2677.5. Then y bar is going to be the distance from here, but in this case we have to calculate 4r by 35 in order to calculate this distance. That will only give you this distance. Then you have to add these 250 to calculate the total distance, because we always have to calculate the distance from this point. So first we calculate this one and add it with 250. That's going to be the total y bar. And if you do that, you will get 120. No, it's 281.8. And if you multiply this one with a, you will get 2489900.26. So this is going to be the ay bar. Now we have all the values right here. Now we need ax bar, ay bar, and sigma a to calculate this x bar and the y bar. That's the main purpose, because this is what going to give the centroid of this object, right? So in this case, let's calculate these all values. So sigma a is going to be equal to, if you add them all together, and before you add that, you have to be careful. This is a hole, so in this case, whenever we have a hole, first we calculate all of them together, and then we put the minus sign in front of the hole. Like for example, this circle is a hole, and I choose that as a part 1. So what I'm going to do is I have to put negative for all of the values. So we are going to calculate sigma a, sigma x bar, sigma a y bar. So since these three are we want, so we have to put negative sign in front of them. So negative this one, negative area, and negative x bar, and negative this one. So when we add together this, we have to deduct this one, and whatever the end value, that's going to be the sigma a. So let's calculate sigma a. So if you add them together and subtract this one, you will get 43508.3, and sigma ax bar is going to be equal to 3263122.5, and ay bar is going to be sigma ay bar is going to be equal to 6894660.26. So these are the three values. Now we can simply plug this into this equation and find the x bar and y bar. So let's plug the values. So x bar is going to be equal to sigma ax bar over sigma a. Sigma ax bar is equal to 3263122.5 over 43508.3, and sigma x is going to be meter cube, millimeter cube, because area time distance, and the area is going to be millimeter square, and both of them cancel, you will get millimeter in answer. So the answer is going to be 75 millimeter, 75 millimeter, and then we have to calculate the y bar. Y bar is going to be equal to sigma a y bar, so it's going to be 6894660.26 over this millimeter cube over sigma a, that's 43508.3, that's millimeter square, and the final value will be 158.5 millimeter. So these are the values for our final centroid points, and let's see where it's going to be it. So for x bar is 75 millimeter, so it's going to be exactly in the middle right here, and y bar is 158.5 millimeter. It means, so this is 250, and let's say so 100, then so it's going to be somewhere right here. So this is going to be the centroid. If this is 158.5 from this base, if this is the height, then this is going to be the centroid, and it's going to be in the 75 millimeter distance. So this is how we calculate the centroid points, and I hope you guys understood this concept. See you next time.